Alright, so we got our limiting reactant situation that we're going on here. Alright, I got the sulfur, I got the chlorine, I have the disulfur dichloride. Now, our first step is we're going to have to go we're going to have to go mass to moles for the reactants. So we're going to go mass to moles for the reactants. So we're going to start with S8. We're going to start with sulfur. So we're going to go mass to moles. So I'm going to say, all right, we have 200 grams of S8. Now, unit analysis says that we need grams of S8 here, and that's going to give me moles of S8. Now, we have to figure out what mass, well, I know that's going to be 1 mole, but what mass are we going to put in down here? Molar mass. Now, how many sulfurs do we have? 8. So it's going to be 8 times whatever sulfur's molar mass is, 32.07. So I'm going to have 32.07, and instead of working on the calculator, I've done this problem twice already today. So it's 256.56 grams. So it's 256.56 grams. All right. Now, my question to you, ladies and gentlemen, is what do we do here with the 200 and the 256? Divide. So we divide these two numbers, and to make life simple for us, we'll get 77.97 moles of S8. All right. Next, we're going to talk about the Cl2. I got 100 grams of this guy. So now I'm going to get grams of Cl2 and moles of Cl2. So my next question is, for Cl2, it's going to be 2 times whatever the molar mass of chlorine is. So that's 2 times 35.45 grams, which is going to be equal to 70.90 grams. So I'm going to get 70.90 grams per 1 mole. So now, what do I do with the 100 and the 70? Divide again. And make a long story short, 1.4104 moles of Cl2. Alright, so first off, anybody got any questions about what the first step is? The first step is go from the mass to the moles of the reactants that you're given. Well, the first step is to make sure you have a balanced equation, but since we have a balanced equation, we kind of skip over that. Second one is make sure that you go mass to moles. So I have moles of each. Everybody okay with that? All right. Now, step 2. Compare the mole ratios. All right, so the first one that we're going to look at is the calculated ratio. So we're going to look at the numbers that we actually calculated. Now what I like to do is I like to put the big one over the small one. So I'm going to put the 1.4104 moles of Cl2 in the top, and I'm going to put the 0.7797 moles of S8 in the bottom. Now, I don't like this at all, because this doesn't tell me a whole lot. So what I'm going to do is I'm going to divide that by 0.7797, and I'm going to divide this by 0.7797. What's 0.7797 divided by 0.7797? 1. And what that's going to do is give me 1 mole in the denominator. And that's one of those math tricks that you use. And what it's going to do is it's going to make it easier for us to take a look at what we're doing. So, if I do this, I know I'm going to end up with 1 mole of S8. And the nice thing about that is, what's the coefficient of S8 in the equation? Look back at your equation at the top. The coefficient is 1. So I know I have 1, so I'm good to go there. That's really nice. Now in the top, I'm going to take that 1.4104, divide that by 0.7797, and I'm going to get 1.8089 moles of Cl2. Now, alright, so that's the calculated mole ratio. The second part I want to look at is the given mole ratio from the equation. So I want to look at the moles of Cl2 compared to the moles of S8. Now, basically you're going to take the coefficients, because that determines the number of moles that you have. Well, how many moles of Cl2 did we have? What's the coefficient in the equation for Cl2? Niet. What's the coefficient in the equation, in the chemical equation at the top? Yeah, it's 4. And what's the coefficient for S8? 1. Now, I need to look also at what we have here. I got 1 mole of S8 and 1.8089 moles of Cl2. Now, take a look at these two. Do I have enough S8 to make this thing go? Are those two the same numbers? Yeah, these guys are equal. Now, if I have 1 mole, this tells me I need 4 moles. Do I have 4 moles? No. I don't have 4 moles. So, we only have the 1.8089 moles of Cl2. So, do I have enough to make the reaction go? I got enough sulfur, but do I have enough chlorine? No. So what's going to stop the reaction? What's going to run out first? The chlorine's going to run out first. So the Cl2 will run out first. And what does that tell me it is? It's the limiting reactant, or reagent, or whatever, reactant, reagent. That's the thing that's going to stop first. So the one element that's going to stop this equation, this reaction, stop it cold, is the chlorine, because it says I need 1 mole and I need 4 moles to make this all happen. So if I want to use up all 1 mole of the S8, I need 4 moles of chlorine. But I only have 1.8089, so it's not going to take all. I'm going to have extra sulfur afterwards. So we've determined that, and that's the big thing is, this is where you have to make that determination. This is where you have to use the most brain power. Because you have to say to yourself, all right, I got enough of that, but I don't have enough of this. So this is going to actually stop it. If I had more of this, like if it was 5-to-1, then this guy would be my limiting reaction because I would have one of these, and then I need 4 total to make it happen, but I have more than 4. If it was it was like 5.2-to-1, I need it 4-to-1. The 5.2, I have a lot more than I actually need. So it's the other guy that's going to happen. This I have less than I need, so I know this is the one. If 1 is more than you need, then you know then the other guy's a limiting reactant. This guy's less than what I need. That guy's my limiting reactant. So step 3 after that, since I know chlorine is my limiting reactant, we need to calculate the amount of product based on the amount used of Cl2, because chlorine is a limiting reactant. So here's what we need to do in this case. First I have to go moles to moles. Moles of Cl2 to moles of S2Cl2. So how many moles do I have of Cl2? I got 1.8089 moles of Cl2. And now, here is the mole ratio from the equation. How many moles of chlorine do I need to make how many moles of S2Cl2? What are the two coefficients? So I need moles of Cl2 and moles of S2Cl2. What are my coefficients? Look at the equation. It's 4 and 4. Because remember, it was one sulfur plus 4 chlorines is going to yield 4 disulfur dichlorides. So it's 4 to 4. What's 4 divided by 4? 1. So am I actually going to multiply or divide by anything? This is mathematically easy. I can get the 1 point. Well, actually, I used the wrong. I used the wrong number here. We should use the 1.1 or 4104 because that's the actual amount that we have. Sorry. This was the altered one that we got from here, where we divided by there. This is the one we actually have to use. So that's what I actually have to use. So I apologize for that. So that's the amount that we have to use. And we figure out that we have 1.4104 moles of S2Cl2. Now, to calculate this, we're going to have to go moles of S2Cl2. And we need to do that and go to mass of S2Cl2. So I need 2 S's, 2 Cl's. So that's 2 times 3207? Is that what it is? Yeah, 32.07. So 2 times 32.07, and that's 2 times 35.45 grams. And putting that into our calculators, we're going to get 2 times 32.07 plus 2 times 34.35. Sorry. We're going to get 135.04 grams per mole. That's our molar mass. So now I'm going to set up and say, all right, I know I have 1.4104 moles of S2Cl2. I know 1 mole of S2Cl2 is going to give me 135.04 grams. Now, what do I do with those two numbers? Multiply them. So 135.04 times 1.4104, and we're going to get 190.46 grams of S2Cl2. So that is going to tell us that at the end of the reaction, even though I don't use up all my chlorine, the chlorine is going to dominate everything and tell us that, all right, because I have that amount of chlorine, I'm only going to get this amount of disulfur dichloride. Go down to here, set it up, do the moles. I did the moles, and then moles to mass. We're going to end up with 190.46 grams of disulfur dichloride. Now, there's one last thing that we're going to have to set up. One last thing. And we got to figure out actually how much of the sulfur is actually left over from the whole thing.